Hi, this is Roopa Prasad, Assistant Professor MCA, MITS College. Now, today we are going to discuss about the concept called as a virtual memory. So, these are the contents. So, first we talk about the virtual memory, then we go for the advantages of virtual memory, then we talk about demand paging, then basic concepts of demand paging, then we talk about the steps in handling page faults, and finally we go for the page replacement. So actually coming to this topic, virtual memory, this virtual memory is a memory management technique. So which allows the execution of a process that are not completely in the memory. Okay, actually there is on requirement, but no, what it is means in order to execute a program, the program must be loaded in memory. Okay, this requirement is necessary and reasonable, but what happens now? This requirement is going to restrict the size of the program. Okay, it limits the size of the program to the size of the physical memory available. So what the operating system is going to do means the operating system is going to introduce this virtual memory topic. By what happens this means the programs are no longer restricted by the physical memory limitations. So, as we are not restricted to the physical memory limitations, we have a reduced physical memory per user program that enables more programs run simultaneously. That results in increased CPU utilization. And this virtual memory involves a separation of logical memory from the physical memory. So, what happens by this means it allows an extremely large virtual memory to be provided that I will show in the slide. So, look at here. So here this is a virtual memory. This is a large virtual memory that we call it as a logical memory. And this is a physical memory. Actually, we are having the limited size of physical memory. Only some frames are available in the physical memory, but this logical memory is entire extremely large. Even though it is extremely large, what we are going to do means we are going to load the entire process in the hard disk, and whatever the pages are required that will be loaded in the physical memory. Okay, and the operating system, the memory management unit, will map this process. Okay, so what it is going to happen means we are going to have the program that can be larger than the physical memory available. Then coming to this advantages, so there are some advantages of the virtual memory. So this virtual memory, by using the virtual memory concept, what we can do means the system libraries can be shared by several processes. That means what the process need not to be loaded. Entire process need not to be loaded. If some process is having some library, that library can be shared by another process also. And this virtual memory concept, what it is going to do means it allows one process to create a region of memory that can share with another process, and pages can be shared during the process creation with the fork system call that we are going to speed up the process creation. Actually what happens means when we give the fork system call, the process is going to be duplicated. The process that is going to give the fork system call, that is a parent process, and the tail process will be created and the tail will be duplicated. So in using the virtual memory concept, it's going to implement copy on write method. That means what whenever we make the changes, then only that is reflected in the child. You understand? So by this purpose, we are going to speed up the process creation. And in order to implement this virtual memory, we are going to use a technique called as a demand page. So in the name itself, we can say demand page. So these pages are brought into memory upon explicit request. That means when only the page is required, then only the page will be loaded in the memory. Thereby, we are going to optimize the memory usage. Why? Because means, for example, if a process is having 10 pages, okay, now the process is having the 10 pages, all the 10 pages need not to be loaded in the memory. Only the pages that are needed for execution that will be loaded in the memory. Thereby, we are going to optimize the memory by using the virtual memory concept. And this demand paging is very similar to paging system with swapping. So swapping means what? The process will be brought into the memory and the process will be swapped out from the memory. If sufficient space is not available for a process to be executed, then another process will be swapped out and this process will be swapped in. Actually, the process will reside in the secondary storage. Okay, more typically, what we can say, we can call it as a disk. So At the time of execution, what we are going to do means the desired process will be swapped in. Okay, actually in traditional paging what happens, all the pages are brought into memory, but here what happens, pages only that are required that are brought into memory. And so this is a this is a swapping process. So what happens? So when a process is not required, so the swapper is going to do means the swapper is going to swap out the pages and they are stored in secondary storage, and whatever is required that will be swapped into the memory. Okay, so here in the concept of demand paging, we call it as a lazy swapper. Why? Because why we are calling it as a lazy swapper means it is not going to swap the page until it is needed. Until that page is needed, then only that will be swapped. Okay, instead of swapping the entire process into entire pages into the memory, what the swapper is going to mean, that swapper is not going to load the page until it is required. Now, for that purpose, we are calling this as a lazy swapper. So, and in the context of this demand paging, instead of calling it as a swapper, we call it as a pager. Why? Because means the swapper is going to swap the entire process, that is manipulate the entire process. But whereas the pager is concerned with the individual pages. So we are calling this as a pager, not as a swapper. And coming to the basic concepts of demand paging. So when a process is to be executed, it has to be swapped into the memory. So what the pager is going to do means the pager is going to guess what pages will be used, what pages will be used. So that pages are only brought into the memory. So thereby we are implementing the partial page loading. That means only relevant pages are brought into memory for execution. So thereby what is happening, the swap time is also going to be optimized. Optimized in the sense it is going to be reduced. So for example, I already told when a process is having 10 pages, so instead of swapping all the 10 pages, it takes time. So what the pager is going to do, the pager is going to do at this right time, what pages are needed for execution, only that pages will be swapped in. Okay, and we are going to reduce the physical memory requirements per process. And in order to implement this scheme, we need some hardware support. So scheme means what? Why we require the hardware support means we have to distinguish whether the pages are in the memory or in the secondary storage. Why? Because we are not storing the entire page. We are not loading the entire process into the memory. So we are storing some pages in the hard disk and some pages in the memory. So there must be some distinction in order to find out the difference. So here we are going to use valid invalid bit scheme. Okay, so in the page table, we are using a column, that is the valid invalid column. So when this bit is set to valid, that means associated page is legal and it is in the memory. So if this bit is set to invalid, that means the page is not valid. Not valid means it does not belong to the logical address of that process. And it is but it is currently on the disk. It is valid means it is currently on the disk, and we will show you that one. So now here, okay, this is an extra column we have added here in the page table in order to have the distinction between what pages are in the memory and what pages are in the memory and what pages are in the hard disk. Now what happens, this is a logical, this is a process. So process is having nearly 8 pages are there. Okay, all the pages are residing in the hard disk. So a few of the pages that are needed for execution are brought into the memory for by page. Okay, so this is the page table corresponding this to this process. So here we see that 0th page is allocated in 4th frame, and first page is not allocated, second page is allocated in 6th frame. Okay, now we are going to give these bits valid, invalid, valid, invalid. The pages which are available in the memory, which are loading in the memory, are given as valid, and the pages which does not belong to the which are not in the memory, they are given as invalid. Okay, so this is a hardware support we are going to give, that is operating system is going to give. Okay, then we discuss the concept called as page fault. Okay, so what is a page fault? Page fault means if a page is actually the page is referenced by CP. Okay, if that page is not available in the memory, then we call it as a page fault. Okay, the referenced page is not in the memory. The reference page is not in the memory, then we call it as a page fault. How we can know that reference page is not in the memory? By using this bit. Okay, so there is a MMU, okay, which is going to translate the physical logical address into the physical address. When this finds it as invalid, what it is going to do means it is going to send a trap to the operating system. Then operating system have to find out the page on the disk, and then that page has to be brought into the free frame. Okay, and it has to update the page table. So it has to make it as valid. It has to give the frame number, and it has to give it as valid, and then it is going to restart. It asks the CPU to restart the instruction. That is a process of handling the page fault. Okay, so page fault is a situation where the referenced page is not available in the main memory. That is a page fault, and the page fault can be handled like this. And we talk about page replacement. So if page fault occurs, what happens? The operating system determines where the desired page is residing on the disk, but then finds, then what it has to do, it has to allocate that page into the free frame. But if there are no free frames available, then what it has to do, there are several options are there. One thing that it can do, what the operating system do is, it can terminate the user process. Okay, terminating user process means what? Whatever execution we have done, that has to be taken back. So actually we are using the demand paging. So demand paging, why operating system is implementing the demand paging? In order to improve the computer system utilization, in order to improve the CPU utilization, it is going to have this demand paging. Okay, so when a process will be terminated, this demand paging is of no use. So for that purpose, what will be done means we are going for the page replacement. Okay, that means operating system is going for the page replacement. So page replacement means what? The page that is not in use will be replaced with the new frame. Okay. So instead of swapping out a process, what the operating system do means it is going to free one frame. Okay, that is not currently in use. Okay, that we call it as a page replacement. And this is a thing. Okay, so we discuss here what is the need of page replacement. So for example, this is one process. It's a multi-programming, means multiple process will be residing in the memory. This is the memory, physical memory, and multiple programs will be residing. So this is think that this is a one process and this is another process. Some pages of one process is allocated and some pages of process 2 is allocated. Now what happens? See here. So the process 1 frames 3, 4, sorry, that one. What is this one? Okay, the second here, this first zeroth page is allocated, then second page is allocated, whereas for the second process, this zero page is allocated as well as this third page is allocated. Okay, now the process is executing this one, the first page. It is going to execute the first page. So first page is allocated in fourth frame. So here it goes. So what is the option here? Load M. Okay, where is M? M is in the third page, which is not allocated in the memory because it is an invalid bit. Then what happens? You have, and there is no free frame available. No free frame available. So if there is a page for what the operating system is going to do, the operating system is going to find out the page and that page will be loaded in the memory. But what happens here? No page is available, no free frame is available. For that purpose, we have to go for the page replacement. That is a need of the page replacement. So what the page replacement is going to do means it is going to select one page that we call it as a victim that has to be swapped out. The page will be swapped out and the required page will be swapped in. That is a need. That is a basic page replacement. Okay, that we are going to discuss in the next session. Okay, and these are the references. And if you have any queries, okay, you can kindly leave your queries here. Thank you.